Welcome to the Teja Statistics. Previous year's important questions of SEM 2 Data Science and BSc Statistics students. Define uniform distribution, obtain its mean. Define Poisson distribution, state its reproductive property. From a consignment, 15 record players are selected at random one by one and examined. Those examined are not put back. What is the probability that ninth record examined is the third and the last defective? Next, question number 4. State the memoryless property of geometric distribution. Very important question. The mean of normal distribution is 60 and 6% values are greater than 70. Find the standard deviation and also probability of 0 less than z less than 1.56 equals to 0.44. Obtain the mean and variance of exponential distribution. Define beta distribution of first kind and find its mean. Define Cauchy distribution, give its applications. A long answer questions for this statistics paper. Define binomial distribution, derive its mean and mode. Obtain beta 1, beta 2 for Poisson distribution, and also comment on skewness and kurtosis. Define hypergeometric distribution, derive its mean and variance. Derive the Poisson distribution as a limiting case of the negative binomial distribution. Derive standard deviation, mean deviation about and quartile deviation of the normal distribution. Show that normal distribution is a limiting case of binomial distribution. Define gamma distribution, obtain its moment generating function and hence find its mean and variance. Derive the moment generating function of exponential distribution. Show that the sum of the exponential random variables is again a gamma random variable. Next question, paper. Obtain the mean and variance of Poisson distribution. Obtain the probability generating function of negative binomial distribution. Write a short note on a lack of memory property of geometric distribution. Define hypergeometric distribution. Define gamma distribution. Define beta distribution of first kind and second kind. Discuss real life applications of Cauchy distribution. Next, part B, the long answer questions. Derive the recurrence relation for moment generating of the Poisson distribution and hence find the movements. Fourth order movements up to you have to calculate. Next, obtain the mean and variance of hypergeometric distribution. Obtain the cumulative generating function of binomial distribution and hence find its first four movements. Next, obtain the moment generating function of geometric distribution and hence find its mean and variance. Obtain the mean and variance of normal distribution. Obtain the mean and variance of gamma distribution. Define exponential distribution. Obtain MGF of exponential distribution and hence find its mean and variance. Next, define rectangular distribution and obtain moments of rectangular distribution. Derive its MGF and characteristic function. The next previous year's January 2021 probability distribution statistics. Define uniform distribution and give two examples. On average, there are 1.8 breakdowns every 5 working days in a major factory equipment at the main ABC factories. Find the probability that there are will be the less than 2 breakdowns during the next 5 working days. Define hypergeometric distribution. Give 2 examples. Define negative binomial distribution and hence derive its mean and variance. Define normal distribution. For normal distribution, show that the median coincides with the mean. Next, x is a normal variate with a mean 10 and standard deviation is 5. Find the probabilities of the following: 30 less than or equals to x less than or equals to 45. And the second question, x greater than or equals to 45. Define exponential distribution. Find its moment generating function. Define rectangular distribution. Derive its mean. Long answer questions are from the part B. Derive the moment generating function of binomial distribution, hence derive the first 4 central movements. Derive the first 4 non-central movements of Poisson distribution through expectations and hence find the first 4 non-central and central movements. State and prove lack of memory property of geometric distribution and also derive its probability generating function. Derive mean and variance of hypergeometric distribution. Also derive the binomial distribution as a limiting case of the Poisson, limiting case of hypergeometric distribution. Derive normal probability density function as a limiting case of the binomial distribution mass function. Next, state the characteristics of normal distribution, derive its mode. Define gamma distribution, derive its moments generating function and hence derive the first 4 central movements beta 1 and beta 2. Next, derive the mean and variance of exponential distribution and also show that x1, x2, x3 and so on xn are an independent random variables having the exponential distribution with the parameters theta and where I equals to 1 to n, and show that z equals to minimum of x1, x2, x3 and so on xn has an exponential distribution with the parameter theta is equals to summation I runs from 1 to n of theta I. Very important previous examination question papers. So please follow the Teja statistics and subscribe and share. Thank you.